One of the things that the database management system software provides, one of the main facilities, is a data definition language. And the data definition language is a language for defining the data and the database. In a sense, it allows you to create a database. Right? It allows you to say which data item you need, what's the name of the data item, what's the type of values that's going to be stored in the data item, is there any constraint on the data item, range of values that it can have. For example, if you're storing the price of a product in the database, so you can say price is a number with a decimal point, and its value that we accept to be stored in the database is greater than 0. So your products cannot have a negative value or 0 value. Then we have got the data manipulation language, where once you define your database, once you said what's the name of the data item that you want to store in the database, what are the type of value, the type of the value, the constraint on the value, the range of values it can have, then you should insert data into the database, and then be able to, once you inserted the data into the database, retrieve the data, access the data, update the data, delete the data if you require. I can't see any reason for deleting any data. We just keep on keeping data. We update, but we even keep, and that's very strange, we even keep the old values for analysis later on. With the data manipulation language, and we had one example last week, with the procedural data manipulation languages, you basically say what you want, and the database provides you that data that you need. You just say, I want student details, student name, address, student number of all the students in this university, and there comes all the details. So the whole idea with the data manipulation language is that you say what you want and you get it. With normal programming languages, when you want something, you have to define all the instructions, step-by-step instructions of where the data is, how to get it, and then your program will provide you with the information. With the data manipulation language, you just say what you want and you get it. That's fantastic, no? This is our dream in life. Just say what you want and you get it. You know? So imagine if I could do this in my normal life. Say, coffee latte, a skinny coffee latte for everyone in this classroom right now. And there you go. You will have it on your desk. So the example is like that. But it can't happen in life. But at least with the database approach, you've got this facility in your hand. You've got the power to say what you want and you get it. You're talking about gigabytes of data just coming to you. Okay. Now that hopefully I have convinced you that the database approach is a good approach, and I convinced you that the 3-layer architecture is the way to go, so we can all do our own jobs without interfering with each other. Now let's move on to more terminologies, more definitions, and prepare you for being able to design databases. To be able to design a database that will have all the data needs of an organization, you need to use a data model. There are different types of data models available. So a data model is a set of concepts that allows you to describe the data that you need. For example, the name of the data, like a student number, a student name, address, the type of the values that may be stored in that, and the relationship between those data. In reality, a data model should provide you with a certain tools for describing the data that you need and the relationship that the data item may have with each other. This may be a new concept to you, that you would understand data, you would understand the user's needs to access data to perform their tasks, but what is the relationship for? Knowing the relationship between two data items can give you more information. For example, imagine we use a data modeling tool, and there are many of them, and data modeling tool, as I said, is a tool that allows you to describe your data needs and the relationship between the data. Let's say we want to store the details of all the students in this university. So the data items that we will store would be the student number, the student first name, last name, address, telephone number, maybe the name and address of your next of kin, right? And then also, let's say we want to store the details of all the subjects available in this university. So we store the subject number, subject name, right? Which faculty it's offered at, or which department it belongs to, etc. So there are two pieces of data that we store, the details of all the students and all the subjects. What's the relationship between the student and the subject? The relationship is established as soon as you enroll in the subject. So the student takes a subject or enrolls in the subject. So now not only we have got the student as one part of our data in the database, we have got subject, and now we created in between the relationship. So the student takes subjects or enrolled in the subjects. And this relationship by itself has got certain data attached to this. And the data could be the date of enrollment, the fees that you paid for that course, the fee of, or that subject. The fee could be stored in the subject, so at least the enrollment date. Right? Do you see that? So now, knowing the relationship and storing the data about the relationship, now we know who is taking which subject. How many students are enrolled in each subject? Because now we have got all this data. A data model provides you with a blueprint of what you are going to store. So it's the same as when you want to build a house, you draw a map, or you get an architect to design a house for you with number of rooms that you require and the locations of the rooms, etc. With a data model, it's a blueprint of the database. That's the design for actual database. Having a data model, and because the data model provides you, it's a tool that provides you with certain notations. And this notation is for describing the data that you need and the relationship. So now, like a architect drawing a map of your house, and you can look at the map and see how many bedrooms are there, how many kitchens, bathrooms, etc. are there, where is the locations of different bathrooms. The data modeling tools provide you with a facility to basically describe the data item, the relationship, and these notations, we can represent it as a diagram, and if we all understand certain data modeling tools, so there's no confusions. So it's not speaking in certain language, English or any other language that may have ambiguity. This notation now, this data model as a diagram, now we can pass to each other, and we all know what data we will store, what relationship we will store. Does this make sense? Right? So it's a good tool for allowing you to represent what you think the database should contain, the data and the relationship, on a diagram that we can show each other. We can improve that diagram. And you as a designer design the database, you provide that diagram to a person that understands this notation and now can build the database using a database management system software.